Okay, we're going to start with 7.3, which is 7.3 is solving linear systems by linear combinations. Now you can think here of maybe a little closer to the substituting method that we just did, a little further away from graphing. This is a way to get a solution without graphing. In fact, it makes it more accurate, just like substitution did. Okay, let's start by the definitions. We'll start with the definitions. What we've got here is we're going to define this as it's an equation found by doing this. We're going to be multiplying one or both equations. Again, we're going to be working with two equations. And I'm going to put a little maybe here, because sometimes you don't do it. And then the thing you always do is you're going to be adding the equations. That's kind of the basic first step. And then we go back to a little bit of substituting. Now, let's go to this piece right here. Our first step is this. We're going to arrange the equations with like terms in columns. In other words, x's and y's kind of lined up is a good way to put it. Now the next thing we do, our next step is we're going to multiply, if necessary, the equations by numbers to obtain coefficients that are opposites. So let's just let's add a little bit to this here. When we talk about these opposites, we're talking about something like, for example, negative 6x and 6x. Those are opposites. The next thing we're going to do is we're going to add the equations from step 2. Again, this is kind of like substitution. We've got some steps here, but they may not make sense yet. We're going to combine like terms, and what that's going to do is eliminate one variable. So we'll get rid of the x or the y, and we're going to solve for the other variable. Now, the next step, again, we're going to practice this too. We're going to substitute the value obtained from step 3 into either of the original equations. And we're going to solve for the other variable. Once we're done, we check the solution in each of the original equations. Okay, we'll go ahead and turn to example 1 and we'll practice.